8:07, we're a little late.
But it's the first, not the second. You know, we had an extra day yesterday.
Yeah,
This is the rest of the semester. Functions. It's actually the rest of the book, and it's actually the rest of pre-calculus and then calculus and all that other fun stuff. It deals with this word over and over again. So you need to know it inside out, upside down, and everything else. It has some weird parts to it, but if you follow my lead and you do exactly what I tell you to do, you should have no trouble whatsoever. It's when you start doing little shortcuts that things start falling apart. So please don't. Before we start functions, we have to define what a relation is. This marker's dying.
Time to get home.
Nah. Time to go home. This one works. And a relation is just a set of ordered pairs. In other words, if you take a piece of graph paper, ordered pair, you all know what an ordered pair is, right?
One and
I'm
two.
blurred in one eye. One eye can see one.
Set of ordered pairs is anything that it can be written as a point, x, y. I'm blind. So if you take a piece of graph paper, you put it on a dartboard, and you just start throwing a bunch of darts at it. Wherever the darts hit the graph paper, that would be an ordered pair. And if you put all those ordered pairs together, you'd have a relation. There's no rhyme or reason behind them. It's just any collection of points that you wish. A function, on the other hand, there's a little bit of organization to it. And it's very clear what you have to do with a function. It pretty much, the definition, the formal one is, for every x value, also known as a domain, there is only one y value. And we're going to call that the range. We can also call the x value the independent variable and the y value the dependent variable. But that just gets all wordy and I don't want to get into it. So for every x, there's exactly one y. The way I think of functions is if you ask someone a question like how tall are you, how old are you, how many answers can they have?
Just one.
Just one. But can two people be the same height or can two people be the same age?
Yes.
Yeah, so that's perfectly fine. So x's basically do not repeat where y's actually do. They can repeat, if you want to think of it that way. So let me give you two sets of relations, an A set and a B set. Let's say this is -3, -2, -1, 4, 0, 5, 3, 2, -1, 7. We'll get to that other weird definition in a second. It's actually the easier of the two. Let's let B be -3, -2, -1, 5, 0, 7, 2, 5, 4, -3. One of these is a function, the other one is just a relation. They're both relations off the bat, but one is specifically a function and the other one is specifically just a relation. Which one's which?
A is not a function, B is.
A is not a function and B is?
Yes.
You sure?
Yes.
Would you
Because
bet
there's
your
two.
grade on it?
Yes, I do.
Okay. A is not a function, why?
Because it has two x values.
-1 here has one answer and its answer is
4.
4. -1 has another one over here, but its answer is
7.
7. And that doesn't make any sense according to the definition. For every x, there should only be
One
one y. And this one actually has 2 associated with it. -1, 4 and -1, 7. Down here, I was trying to trick you. Where was I trying to trick you? I lost it.
The 5 and 5.
The 5 and the 5. A lot of people see this and they're like, oh, that can't be a function. But that's perfectly fine. Because -1 height is 5, And 2's height is also 5. 2 people could be the same height. That's perfectly fine. So the top one is not a function. And the bottom one is a function. Okay. Let's think of it graphically. If I have 2 pictures, again, one will be a function, the other one will not be. And let's see, I'll draw this one like that, and I'll draw this one like that.
A is not.
A
And
is
B
not a
is?
function, and B is.
Why? Don't you
Because,
dare say anything about a test.
Vertical line.
Aha.
because you can go through A twice.
If I go through and pick an x value here, let's call it x sub 1. If I go up, it hits the graph twice. That means for this one x value, there are 2 y values, y1 and y2. So that one cannot be a function.
So we can't have 2 Y values.
Two
Definitely.
X values.
For a single x, there cannot be 2 y values. In other words, in a graph picture, they can't be above each other.
Okay.
They can't be above each other.
So no line can't go
So-
through 2 points.
We'll get there. We'll get there.
Any given X.
Any given x, just one x, if it has 2 y values, it can't be a function.
Be crazy.
Now this one over here, if I pass a vertical line through this x1, it only hits the graph
One.
once. And if I move that vertical line through this function left to right, it never ever hits the graph more than once. So where this one's not a function, this one is a function. Fancy name for this test, of course, is if a vertical line hits a graph more than once anywhere, it is not a function. A vertical line hits the graph anywhere. It just has to happen once. So let me draw you 2 more pictures just to mess you up. Again, I'm going to draw one as a function and the other one is not a function. Okay, let's see. This is what's called a piecewise function. It's broken into several pieces. So one of them is a function and the other one is not.
Oh, the first one is not
Why?
because it has 2 points.
What does closed circle mean?
They
It's
What does closed circle mean?
is
It
The
stops
absolute.
right there.
Equal to, and it's
Equal to.
included.
Okay.
What's open circle mean?
It doesn't.
Not
It's
equal.
Not
It
included.
needs to go.
So if I pass a vertical line through this, it's only going to hit once pretty much everywhere, right?
Mhm.
Except maybe possibly here. Now, does it hit both of them? Yes, it hits here and hits here. So therefore this one is not a function. What about this graph?
It is
Why is it a function
because
here?
it has an open circle.
Because if I pass a vertical line through here, let's see if I can hit both of them. It hits the top one up here, but does it ever touch this one?
No.
Because it's not even,
Included.
it's not there. So an open circle means the point is not
Included.
there. So it hits only once, so this one is a function.
So what's the point of even putting that on there? Just to,
Huh?
just a trick or something?
No, I have to put something here to indicate that it's not there. Otherwise, you'd see, that, and that doesn't mean anything. You couldn't tell one way or the other. So if a graph ends, like I want it to end right there,
Mhm.
I have to put the point.
So when it's open circle, it's just
It's not there.
okay.
It's getting really close to it, but it's not there.
Okay.
Like if this was the coordinate -1, 7, -1, 7 would not be part of the graph.
Oh, okay. I didn't
But
know.
all the points up into it,
Okay.
really, really close to it, are part of the graph.
Okay.
It's just that one point I just kind of took it out
Okay.
and removed it. So that's probably as tricky as I can get with that type of problem. So another way of looking at the definition of a function is x do not repeat for different values of y. For different values of y. But I'm not going to write that one down because I'd rather you go to the pure definition.
So what would be the difference in the coordinates then?
What do you
The
mean?
coordinates will be the same?
Well, the coordinate of the empty spot is the same as the coordinate of the filled spot. It's just this one has the point in its set.
So that one has the equal bar line?
Right, and this one says it's all the points up and to, but not including that one. It's kind of like if we listed it out in a set, that point would just be missing. I would just erase it and it would be gone. But all the points coming up to it, how many are there? Infinite number. So we can get as close as we want, but we just can't touch it. All right, let's talk about determining if an equation is a function. This is where most people get stuck. If you get lost in this chapter, there is a hidden direction. The hidden direction is this. Kind of like if you're dealing with a quadratic, you want to get it equal to 0 if you get stuck, and then go from there. If you get stuck with functions, the best thing to do with a function is solve for y, and then go from there. All right, so let's say we have, for example, now, the answer to this question is a 50-50. It either is or it isn't. So here's the thing. You can't guess. You have to tell me why it is or why it is not. That way I kind of understand that you understand what it means to be a function. So the hidden direction, of course, is solve for y. So how do you solve for y?
Subtract x squared.
Subtract x squared, and you get y squared is equal to 9 minus x squared.
Then you square root.
Square root both sides, and you get y is equal to the square root of 9 minus x squared.
And then you say it is a function.
And then I say you forgot something.
Plus or minus?
Plus or minus.
Oh,
Thank
that's
you.
right. That's right.
Yes, you can hear. Now, with that plus or minus there, let's look at it as a single point for a second. Let x equal 0. What does y equal? If x is equal to 0, what is y equal to?
Plus or minus.
Plus or minus,
9. Square root of 9.
which is
3.
3. So y would equal plus or minus 3. So that means in coordinate terms that we have 0, 3 is 1 point, and 0, negative 3 is another point. What's wrong with that?
The zeros are in the x.
No, it's the negative.
There's 2 zeros. You can't
There's
have
2 zeros and 2 separate y's, and x's cannot
Yeah,
repeat over different values of y. So this is not a function. Repeating,
zeros.
no, we're just
X.
repeating domains or x's or whatever you want to call it.
Okay.
For different values of y, of course.
Oh.
Okay, so that one is definitely not a function. Hey, by the way, can it be written as 3 minus x? You know, the square root of
No.
9 minus x squared, 3 minus x? Please don't. Whenever there's pluses and minuses, just leave it alone. Especially if they're in
Is
parentheses.
that a question mark behind the y equals?
Yeah, I was asking what y equaled, and
Okay,
we came
okay.
up with plus or minus 3. Example is x cubed plus y cubed equal 8. Oops, equal 8. A function.
Yes.
Are you sure?
Yes.
Why?
Because when you solve it for y,
So let me give you a suggestion for the test.
I mean, because I
Solve it for y.
Yeah, solve it for y, but
So you get y cubed is equal to
8 minus x cubed,
8 minus x cubed.
cube root.
Cube root both sides. Do I have to do a funny adjustment in front of a cube root?
No.
Do I need a plus or minus?
No.
Definitely not. Even indexes, you have to do the plus or minus. Odd indexes,
You don't.
leave it alone. So if I pick a value for x, like let x equals 0, what do we get for y?
8.
No.
No. Wait a minute.
Two. Just 2. The cube root of 8 is
2.
2. You're thinking square root of 8. So we get the singular point, 0, 2. Now that's not a proof that it is a function, but if you choose more x's, all you're going to get is one y, one single y. So in this case, is a function. And one way to think about it is, if you type this into your calculator and you just kept choosing different values of x, all you're doing is a calculation, and your calculator's giving you how many answers? One. Calculators work on functions. They only work with functions. They do not work with relations.
So because of the plus or minus over here, that's why we got the -3.
Right.
And over here, it's no plus or minus.
So therefore, for every x, you only have one y. For most x's, I'm not going to say for every x, but for most x's over here, you're going to have 2 y's.
So it kind of depends on the power then?
But yeah, it has something to do with the power. Where this one is even, you're going to get plus or minuses. Well, those will turn out to be not functions. Where this one is odd.
Then you don't have to do plus or minus.
Right.
Okay.
So does that become the golden rule then? If you have an even power and odd power? No. Because then I can ask something like this. And I'm not going to write out the directions, but is this one a function? The absolute value of x plus y is equal to 7. What do you think?
I think it is.
You think it is?
Mhm.
I like being the, what is that called? Instigator? Devil's advocate. That's good. So before you even answer this, solve it for
Why?
y and see what you get. So when I subtract that absolute value of x over, I'm going to get 7 minus the absolute value of x.
Mhm.
So if I choose an x, how many y's do I get?
1.
1. If x is positive, the absolute values just drop off and you get 7 minus a number, and that's just a single number. If the x is negative, the absolute value of that would make it positive, and you go 7 minus a number, and that gives you one answer. So this is a function. Even though, if you want to think about it, the other class I started teaching this and I went in the wrong direction, that absolute value of x becomes positive x and negative x. But that all only depends on what the value of the domain is, not the range. All right, what about this one then? Let's move the absolute value. Ooh, let's put it on the y here. X is equal to 7. Is this a function?
Yes, because you're still solving for 1.
Really? Okay. Solve for y and you get the absolute value of y is equal to 7 minus x.
Then you
Remember, I'm trying to solve for y here. What do I have to do with absolute values?
plus or minus.
I have to split them. Because I'm trying to solve for y, I'm going to have to split it to see what happens.
2y.
And when I split it, I get y is equal to 7 minus x, but I also get negative y is equal to 7 minus x. And the problem with that is, choose any value of x, how many y's are you getting?
Getting 2.
I'm getting 2. So this one is
Not a function.
not a function. So pretty much the golden rule is this. If you have an equation and you see just y, guaranteed it's a function. If you see an equation and you see y squared, guaranteed it is not a function. Only y that you see is a y squared. If the only y you see is a y cubed, guaranteed it is a function. But pretty much it boils down to be very, very careful if anything funny is done to the y. Y squared, y cubed, and absolute value of y. Those things will create some difficulties. So be careful of that. But still, the golden rule is solve for y and be able to describe why it is or why it is not a function.
Before you... Okay.
If I ask you, find the y-intercept, and I'm only looking for one answer, what's the other piece of information I have to give you?
What is the value of x?
No.
No?
If you're looking for a y-intercept, you know the value of x. What is the value of x if you're looking for a y-intercept? 0. So what's the other thing that I need to tell you? I only want one answer. What is the y-intercept?
For what? I mean,
What do you mean what?
What is
For that equation.
What is the
Which
x-intercept?
Which equation?
yeah.
I have to tell you which one I want you to talk about. So there's ways of talking about it. I can talk about the top one and the bottom one. It's not very mathematical. I could talk about, we can call this like y1 and this one y2, but y1 and y2 later become fixed values. So what I'm going to do next is, well, name them. So let's call the first one Frank. The They think I'm joking. And the second one, George. Now, if I change my question, find the y-intercept of George, you know which one to look at. Which one do you look at?
George.
George. And what is the y-intercept of George?
4x plus 7.
Stop it. What is the y-intercept of George?
1.
Holy Christ. What is the y-intercept of George? How do you find a y-intercept?
7.
Ah, it's a singular value. I'm talking about a piece of graph paper. If I was going to plot it, what is the y-intercept of George?
The y-intercept
What's
is
that?
7.
4x plus 7.
No, you gotta refresh us.
You don't know how to find a
No,
point?
I know how to find
So
it.
don't you replace
Put it in
it?
the
Oh.
table.
Replace the x with 0, so you get y equals 4 times 0 plus 7.
I said it.
So y equals... Oh, I didn't hear you. I'm sorry. You said that?
I said it.
You said that way back there. I didn't hear you. So the point is 0,
You
7.
say 7.
I heard 7. I don't want to hear 7. I want to hear 0, 7.
Oh.
It's a point on a piece of graph paper. So saying the y-intercept is 7 is irrelevant because it only has one coordinate. Okay, so what if I asked you to find the x-intercept of Frank? How do you find the f-intercept, or the s-intercept? There's no such thing as an f-intercept. Find the x-intercept of Frank.
0.
You put in 0, 4, y in Frank, which would be 0 equals 3 minus 2x. Then what?
Then you subtract 3 from both sides.
Subtract 3 from both sides and we get this.
And then you divide -2 from both sides.
And you get
Negative 3 halves.
3 halves. So what is the x-intercept?
3 halves 2. I mean 3 halves 0.
3 halves 0. 3 halves 0. And we can answer the question rather quickly because now I know which one I'm talking about, the top one and or the bottom one.
Why did you zero out y-intercept?
When you're doing a y-intercept, you let x equal 0.
Uh-huh.
When you're doing an x-intercept, you let y equal 0. All right, except I don't want to be talking about Frank and George through the rest of the semester, so we're going to kind of shorten it. Instead of Frank, we're going to be talking about just his first letter, which is F. And F works with the variable x. So when you write this, this is not F times x, this is F works with a domain of x. So I can also write F of A, and then just replace all the x's with a's, and then we're having Frank work with a bunch of a's. The George, of course, is going to be G, and he's going to be also working with a bunch of x's. Now, f of x, of course, is equal to 3 minus 2x, and g of x is equal to 4x plus 7. So now if I ask a silly question, let me bring it over here. It's going to take up a little bit of room. It's an older question that you've been asked before. Let's do the old notation first. Yeah, this number will be fine. For example, find y when x is equal to -3 and y is equal to 3 minus 2x. What would you do?
Substitute.
You would take the -3, you plug it in for x, so you go y equals 3 minus 2 times something. That something happens to be
-3.
-3. -2 times -3 is? 6 plus 3 is 9. The problem with this question is we're talking about a piece of graph paper because we have an x-coordinate and we have a y-coordinate. And the difficulty here is y is way down here by himself,
And
x is way up here by himself. And you have to be able to take those two pieces of information that are in two different locations and bring them
together.
in the correct order. So when I write this as a coordinate,
X is -3.
x is -3 and y is
9.
9. That's kind of awkward. It's very awkward. Two things that are awkward about it. The directions are too long because it's a very simplistic thing that you're doing. And the answers end up in two different locations. So let me ask it as we're going to ask it in this class. That takes care of the entire question. This says, find y when x is equal to -3. See, this used to be f of x. And I took the x and replaced it with -3. So that takes care of this piece right here. It tells me what x is equal to. This f of -3 is actually find y. Because f of -3 represents the y coordinate. No. The -3 represents the x. F of -3 represents the y, the answer of it. So when we plug in -3 here, it looks exactly the same. And we still get the same answer, it's just this is where it becomes nice. You get f of -3 is equal to 9. When you go looking for your x and y coordinate, your x is right here, and your y is right there, they come down together. So I can write my coordinate as -3, 9, and be done with it. So, where this one you have directions that were really long, the directions get really short. Where the x and y's are separate, this one keeps them together, which is beautiful for, not making silly mistakes.
Kind of like substitution.
Go ahead.
It's kind of like substitution.
It's still substitution. It's still substitution. It's just a quick way of being able to reference functions when you have many of them.
Oh, it's just easy.
And it makes life easier notation-wise. And there's a lot of other little neat tricks that we'll be dealing with throughout the semester.
That was in math 8.
A little bit of it, not a lot.
Yeah,
A little bit of it. The basics.
The basics.
This junk. So, for example, if I give you f of x is equal to 4 minus x squared, and g of x is equal to let's make it ugly. 2x plus 3 over 4 plus x. I want you to find f of -2. Now these questions are good because it tells you what function to look at. So you look at the f, and it tells you what to plug in. This -2, remember, represents the x. It's telling you literally that x is equal to -2. So when you see that number on the inside, that's your x value. The whole thing, f of -2, this is your y value. The entire thing. So you're writing x and y in one term rather than having it separate. Okay, so how do I find f of -2? Well, you take your function and you replace all the variables with empty parentheses. This is the one thing I need you to do for this entire chapter. If you're working with a function, that should be your first step. Get rid of the x in this position, get rid of the x in this position, and just replace them with parentheses. The function should look exactly the same, except it has no x's. That's it. And a bunch of parentheses in place of it. Inside the parentheses, we need to put -2. Whatever I put inside the first parentheses, I have to put in all of the rest of them. So this one also gets -2. I know it's still substitution, but again, this is just a number. It doesn't have to be a number. I could say f of a boat, and guess what you're going to have to put over here? A boat. Or f of a triangle, and better over here would be a triangle. Remember when you did pre-algebra and they would do 2 square plus 4 equals 7, and you had to come up with what was supposed to go inside the square? Same idea as what a function is. All right, what's -2 squared?
4.
So this becomes 4 minus 4,
0.
which is 0. So my answer here is f of -2 is equal to 0. What's this coordinate?
-2, 0.
-2, 0. What's this called?
A point.
Yeah, great. X-intercept.
Uh,
It's a fancy point because the y-coordinate is 0. Or if the x-coordinate is 0, you'd call it
the y-intercept.
a y-intercept. Might as well get used to the language. All right, let's make it worse. B. Find g of...
You have it up there, right?
Yeah, g, right there. -3. Find g of -3. George. Now we're looking at the George function. And the George function is a little bit more complex, but no big deal. This becomes g of something is equal to 2 times something plus 3 over 4 plus something. I know this step is trivial, but it becomes really, really important later. So if you get used to it now, life becomes easier for you later. If you do shortcuts now, it's just going to punish you later. What goes inside the parentheses here?
-3.
And inside every single parentheses afterwards. Okay. What do we get? Well,
-6 plus 3.
g of -3 is equal to,
-6 plus 3.
which is better known as,
-3.
over
1.
1. So you get this coordinate, which is -3, -3. Just one silly question. What's g evaluated at -4?
In the same problem.
Say, yeah, why not g of -4? I'm telling you what function to look at, which is g, George. You look and find a George above it. 0?
It's 5, man.
Don't you dare touch a calculator.
I'm sorry, but that's me.
So it's 2
If you plug in -4, you get 2 times -4, which is -8. -8 plus 3 is -5.
So it's
-5 over 0.
Huh?
So it's -5.
0.
Zero.
Undefined! Oh my. Did you say that?
I'm trying to say that, but I can't get the word.
Undefined. So what does it mean when something like this is undefined at a value? What it means is -4 is not in the domain of G. In other words, -4 could not be in the domain because you can't use it. You can't use it because it's undefinedness.
-5 over 0 is undefined.
You can't divide by 0.
I'm thinking, I don't know.
You're thinking the 0 property?
I guess.
0 times, it's not 0 divide. What if I asked this question? F of a minus 2. F of a minus 2. Oh no, it's not a number anymore. How horrible. So if I'm going to look for f of a minus 2, the function I need to look for is Frank over there. And Frank looks like this. Frank takes something, and it goes 4 minus that something squared. In this case, what's the something?
A minus 2
A
squared.
minus 2. So I put a minus 2 in here, so it matches up with this one. And then because it's a minus 2 in this parentheses, I have to put it everywhere else. What's a minus 2 all squared?
4 minus.
A squared. Plus 4.
It's a squared minus 4a plus 4.
I got you all incorrect.
Yes, you do. You have to FOIL it out. A squared minus 4a plus 4. Why? Because it's a minus 2 times a minus 2. And it has to be FOILed. Now notice also, because of this minus sign, I put a bracket or a parentheses to separate it away from the problem, so you distribute it. So you get 4 minus a squared plus 4a minus 4, which is equal to?
The bracket doesn't matter whether you use a parentheses or a bracket.
Yeah, I like brackets to really emphasize that there's a
Negative
minus
a
sign up
squared
front.
plus 4a.
What is it?
Negative a squared plus
I'm going to write it as 4a minus a squared. It doesn't matter, but I like putting minuses in the middle. So if I bring this down, I get f of a minus 2 is equal to 4a minus a squared. Great. This first one, we found a coordinate -2, 0. The second one, we found the coordinate -3, -3. What is the coordinate of this point? What's the x-coordinate?
It's
A
a minus 2.
A minus 2. What's the y-coordinate?
4a minus 2. I can't see. Okay, a squared.
I can't see. You have it on your paper. 4a. Now you got me saying 4a minus a
You would
squared.
leave that 4a minus a squared like this.
That's the y-coordinate.
I think
What
she's
else can I
saying you
change
want
it
to
to?
simplify the 4a. Could you simplify?
See, y'all teach us one thing in one chapter and then the next
Whoa, what would you do with this?
factor out of a.
You could, but what would be the point?
It would be really long.
No, factor out the a. You'd have a times 4 minus a. But what would be the point? It can't simplify. There's nothing to divide out. You might as well just leave it alone. Don't do any extra work. You only factor when you simplify or combine fractions.
Yeah.
One of my favorite test questions. F of x is equal to x squared minus 2x plus 3. G of x is equal to 4x cubed plus 7. Why not? And my question would be 3 times f of x minus 2 times, not f of x. 3 times f of negative 3 minus 2 times g of negative 2.
What did you do?
I forgot my times. To emphasize. Okay, so I would tell you two functions, f and g, and then I'd give you this nice little thing here, and I'd ask you to find the answer. Okay. What would you do first?
So again, what substitute?
Or do
What
it, I would
F
write
is and what G is?
Find the two pieces you're missing, which are
F and
f of negative 3
G.
And G.
and g of negative 2. Do them separately. Don't do them inside the problem. Pull them off to the side, find their answers, plug them back in. So you go off to the side and you find f of negative 3. How do you find f of negative 3?
Do your little bracket things.
Do your little parentheses for every x. And inside the parentheses goes
Negative 3.
negative 3. And negative 3 squared is
9.
negative 2 times negative 3.
6.
And all of this adds up to
15. Well, 18.
15. Oh, I see what you're doing. You're doing one at a time. And f of negative 3 is equal to 18. So I'll replace this whole green box with 18. Before I do that, though, I want to find g of negative 2. So g of negative 2 is equal to 4 times something cubed plus 7. The good thing about doing this is you're focused on what the function looks like rather than what you're plugging in. It's actually more important to get your function down correct. I've seen people drop the 7. I've seen people drop the cube. I've even seen people drop the 4. So be really careful. Get the function right. The number going in is actually irrelevant because it can always change. But the function has to look like that. Negative 2 cubed.
Is
Negative 8.
Negative 8 times 4.
Negative 32.
Negative 32 plus 7.
25.
Negative 25.
Negative 25.
So I get g of negative 2 is equal to negative 25. So I can come back up here and I can say, well, this is going to be 3 times something minus 2 times something. I'm not erasing the f and I'm not erasing the g. I'm replacing them. F of negative 3 is equal to 18. G of negative 2 is equal to negative 25. So 3 times 18, 54?
104 is the answer.
Ah. Fine, 104. Calculator people. But that's like one of my favorite
54 minus 2.
evaluating a function questions. I'd rather not ask you something like, well, what's f of negative 2? Because that's kind of boring. I'd rather put it in this and make sure that you really understand what it means to be 3 times a function. Okay, what's that leave us? Ooh, that leaves us a lot. The horrible part.
So the final answer is 104.
104.
We have to do any coordinates, like
No. See, this is your x coordinates for both f and g, but you're just calculating an answer, so you're coming down to just a single answer. This is not a point anymore because your domains are different. It's just looking for an answer. All right, here's the hard part. Here you go, Merry Christmas. Picture time.
not a function. I mean a function.
They're all functions.
Okay.
We're beyond what is a function. We're working with functions now. All right, we're going to start with the first one, top left. And I'm going to need to sketch it just to be able to talk about it. This becomes, for some people, the hardest topic. I don't know why, but they don't like reading the picture of a graph. And I have to teach you how to read a picture of a graph. So the first one looks something like this. And it's a parabola upside down, all that fun stuff. And this is going to be a function, so we can call it f of x, g of x, h of x, you know, Henry. We can always throw Henry in there. And the questions I'm going to be asking about a picture is what is its domain? Now, when you talk about domain, what are we really talking about?
Domain is the farthest point to the.
Yeah, but what values?
Oh, the
X.
X value.
So when you're talking about domain, you're talking about x-axis only. You could care less about y values. So when you talk about domain, it's left to right. Left to right, and you're only concerned about x values on the x-axis. So when I come across this arrow over here, which way is it pointing?
Down.
That's one of the ways. Which other way is it pointing?
Down to the left.
But see, down has nothing to do with left and right. Domain goes left and
Well, it's going towards that way.
which way?
To the left.
To the left. So when you see these arrows, they're actually doing two things. They're either going up or down, or they're going left and right. It has to be both of them, because that's the only motion you get in a rectangular coordinate system. Therefore, this arrow over here is pointing down and to the right. So when I ask what is the domain of this value, you start with the smallest value, which is way to the left as far as you can go. How far to the left can I go?
Well, if you use it on
Infinity?
the graph, you would say, I guess, 8.
That way's infinity? Negative infinity. So the domain of this function is going to start someplace in negative infinity, way off to the left. And then as you come back towards the origin, we have a graph, we have a graph, we have a graph, we have a graph. How long do I keep that graph as I go to the right?
Keep going.
Infinity.
Forever. So this would be negative infinity to positive infinity. In other words, all real numbers. Every single real number you can think of works for this graph. So you can plug in all x's. All right, the second question I would ask, of course, is range. Now, when you're talking about range, what axis do I want to look at? This is y-axis. This is the only one out of all the things I'm going to teach you that works with the y-axis. So the only time you look at second coordinates is range, or up and down is only for range. Everything else is going to pull off the domain. All right, so when I look for the range, you start as small as you can get, which would be down. How far down does this go?
Infinity.
Infinity. So it would be negative infinity. And then you come closer to the origin, and you move up, and you move up. There's a graph, there's a graph, there's a graph, there's a graph, to this point right here. What is the coordinate of this point?
5.
5.
-3.
Negative 3, 5. Now, because we're talking about range, we have to talk about the y-coordinate, which is
The Y.
5. Now, is it parentheses or bracket?
Right.
Because that point is a point on the graph. It is included. Now, there's a fancy name for that negative 3, 5. The fancy name for this point up here is a maximum. A maximum, because it's the highest point of the graph. Now, because it is the singular highest point of the graph, there are no points any higher than that point, we're going to give it a fancier name. I'm going to call it the absolute maximum. There are no points on this graph that are bigger than that one. The absolute maximum. Every other point of the graph is lower than it, smaller than it, has a smaller y value.
Is there a difference between the absolute and absolute maximum? Or maximum and absolute maximum?
There's two types of maximums, and I will talk about both of them. This is just the absolute max. It happens to be the biggest one. And when you answer it, if I ask you what is a max or a min, you would say the absolute max happens
At -3, 5.
when x equals -3 with a value of y equals 5. When you're talking about absolute maxes or absolute mins or maxes and mins, you have to say, number one, where it happens, and number two, the value it obtains. What's the y-coordinate, basically. All right, some other little questions I can ask about this graph before we get on anything deeper. I could ask, this is the function f. So I can ask silly things like, what is f of -6? What is f of -6? Well, when you see this question, the first thing your eye should be drawn to, of course, is that -6. What does it represent?
The X.
The x. So in your head, you have to say, oh, well, x is equal to -6. So where do I go on my graph?
To the negative
To
6.
-6. Now -6 happens right about here.
Mhm.
This one's not going to be exact, but what you do is you go up to the picture, you find out what its y value is equal to. So if you go up to the picture, you can use your pencil and whatnot and draw right on the picture. Go up and over, what's the closest integer that it falls on?
What, 1?
0. Well, the origin, right?
No, I would say closer to 1.
1.
Maybe a
That's what I
half.
said, 1.
Maybe a half. Hard to tell with this graph. So I'm going to just put approximate in here. 1. It's approximately 1.
But I must be looking like mine is on 0.
It is not.
It's not. You're not going up high enough.
6 starts here. You have to go up to the graph.
Oh. I'm thinking carrying
Let me go for another one. What about f of 2? Where would f of 2 be? Well, f of 2 is someplace over here, and you'll have to go down to get to the graph. When you go straight down and over to the y-axis, what's the closest number that we hit?
-6.
Actually, a little lower.
8, 7.
7. I think it's about -7.
Okay.
So you go straight down, and then you go over to the y-axis. It'd be about -7. One that's a little bit better.
I'm running out of room.
How about f of -5?
F of negative. You go up 1, 2,
It's going to be 3. 3?
It'd be exactly 3. Okay. What if I asked you f of x is equal to 3?
F of
Now what am I telling you?
You're telling me that y is 3?
This is telling me that y is equal to 3. So you have to go on to your graph, you go up to y equals 3, and you draw a horizontal line. How many times does it hit the graph?
Twice.
So there's got to be 2 answers.
So it's going to be
Well, I know one of them.
-5 and 1.
-5, 3 is right here, so -5 is one of the answers,
And -1 is the other.
and -1 is the other.
Do what now? Okay, slow down. You said.
Go to y equals 3 on the y-axis, draw a horizontal line, horizontal line, This way. Parallel to the x-axis.
Okay, and it's
And it hits the graph twice. Where does it hit it?
at -1
-1 and
-5.
and -5. Those are your 2 values. Alright, let's get through these pictures quicker.
So let me erase that little point right there.
You would ask us about the men on these.
Not yet.
Will you
Whoa!
stop that?
Yeah. But this graph didn't have a min because it was going for ever down.
Well, he mentioned Max on this.
He wants min.
I
He
know
wants it.
he's the only one that already knows what's gonna happen next. So you scare me when you said we're not gonna talk about me, and then I get in my head, oh my God, I gotta learn something else.
Yeah, you do. Here it comes.
I just wanted to come naturally.
Okay, say that.
Let's see if I can draw this picture decently.
Now is that pointed cut off on our sheet because it's cut off on our
Oh,
sheet?
there's an arrow at this one. It did get cut off.
Is there any time that one of the lines aren't going to have an arrow on the top or the bottom of it?
Now, if it doesn't have an arrow, it's got to have either a solid circle or an open circle. So if it doesn't have a solid or an open,
Here goes for infinity.
there's an arrow.
Yeah.
Yeah, you just can put one there. If I want it to end, it's going to have
Right.
a solid circle. Okay, so let's start with domain real quick. I'm going to abbreviate it. D, instead of writing out the whole word domain, just write D colon. What is the domain of this function?
Negative infinity into infinity.
Negative infinity to positive infinity, because this arrow over here is pointing to the left, and this arrow up here is pointing to the right. So this thing is going over the entire real number line. X-axis, the entire real number line on the x-axis. All right, what's the range of this thing?
It goes from negative infinity
Because this one's pointing down.
to -2, right?
No.
No?
That one's pointing down. This one over here is pointing up.
So it's positive.
Oh, it keeps going on.
Negative infinity all the way to
Positive.
positive infinity. All real numbers. So this one covers everything, every quadrant, forever and ever. So that's not the interesting part. The interesting part is this. We have a special point. We actually have 2 special points. This one is special. What is the coordinate of this point?
-3, 4.
-3, 4. The other point of interest is this one way down here. 2, -2. Now, is -3, 4 the highest point of this entire graph?
Yes.
No.
No.
Because over here on this branch on the far right, it's going off to infinity. So that's going to be the biggest value, but you can't get there because it's infinity. So this is a maximum, but it's only a maximum if you look in its neighborhood, what's called a neighborhood. So we're going to call this point a local max. Or a, the other word for it is, it'll come to me.
It's not got to.
Relative max. Local or relative is the same thing. So in its neighborhood, it's kind of like being the richest man in town. Are you the richest man in the world?
No.
No, but you're the richest man in town. You're just richer than everybody in your neighborhood, but that doesn't mean you're the richest of everybody. So this is a local max, but there's richer people over here to the far right. He is taller than everybody else around him. They kind of get sunk down below. This point over here, this 2, -2, is at the lowest point of the entire graph.
No.
No, because way over here to the left, it's going off to negative infinity. So this one is not a absolute min. This is a local min. Some books call it, what was the word I said? Relative. It's relatively minimum in its neighborhood. It's like Mr. Rogers. In my neighborhood. Okay, so the other questions I can ask about this one are, what's a good one? Oh, we'll start with this one. This is the function g. I think I labeled it, didn't I? No, I didn't. Let's call this g of x. And I'm telling you that I want to find g of -4. What's g of -4 equal to? How would you find it? You come over here, x is equal to -4, so you go to the x-axis at -4.
Oh, it's 3.
And you go up to the graph until you hit the graph, and then you look over there on the y-axis for its value. So how far up did we have to go? For
3.
3. So this would equal 3. Okay, what about g of 2?
Go down 1, 2.
So g of 2 is equal to?
-2.
-2. And you can see why. Over here the coordinate is 2, -2. So g of 2 is equal to -2. What about g of x is equal to 0? What am I finding when I take the function and set it equal to 0?
You find that the x, because you know y is 0.
I know, but what am I finding? What are they called when you're on the x-axis?
The y, wait.
When you're on the x-axis.
Yeah, because you're saying y is equal to 0. So that is the x-axis.
That's the old one.
When a graph crosses the x-axis, it's called x-intercept. So this is a fancy way of saying, find me the x-intercepts. G of x is equal to 0 is the same thing as saying, find me the x-intercepts. So what are the x-intercepts? Well, there's 3 of them. One here,
5,
one here,
0,
and one here.
and 3.5.
Yeah, sure.
-5, 0, and 3.5.
Approximately 3.5.
I guess
Yeah,
that
about 3
little
points.
squiggly is
Approximate. Yeah. Approximate. I don't like doing approximations. Like my test, it won't be approximates. It'll be a solid point and you'll find it, yeah. These I made up really quick. We had time. Next picture, which is horrible.
Yeah.
This is a piecewise function. It's broken into, well, pieces.
Okay, explain to me again why this is a function.
Which one? Oh, let me draw it first. Remember, every vertical line can only hit one point.
Because the closed circle means the line stops there.
And it's included.
It's included in that coordinate.
But the open circle means it's not included
But that one, up to that one, but not that one.
So it's an invisible.
point, basically.
It's a point that is not there.
Yeah. You just skip it on the
It's
graph.
missing. Now, the importance of these graphs is that you find what the coordinates of all these endpoints are. If I give you open circles and closed circle, the best thing to do is just find their coordinates. So what's the coordinate of this open circle way down here to the left?
-6, +1.
-6, -7,
Okay.
because you have to go down.
The X and Y. Okay. -6.
What's the coordinate of this point here?
-2.
-2, comma, 1. What's the coordinate of this point way up here?
-2, 5.
-2, 5. This one way down here?
-1, 2. No, -1.
1, -1.
Okay, you all got it.
It's 1, -1.
1, -1. Okay, and this open one up here?
3, 2.
3, 2. Okay. So this is a piecewise function. It is one function. Even though it has many, many pieces, it's still considered one function. Is it a function?
No.
Why?
Yes,
Too
it is.
much stuff.
The only place that might be interesting is this point right here. But if you drop a vertical line through 2, 5 and -2, 1, how many times do you hit the graph?
Once.
Just once. The other one's missing. This one's included. So it is a function. And I won't give you one that's not. Unless I'm asking, is it a function? So the first thing I want to talk about is the domain. How far to the left does this graph go?
Infinite, negative infinity.
No, it does not. Do you see any
No,
arrows over there?
Oh,
Which one?
but that's the open circle though.
-6.
As far left as you can go, and we're moving along the x-axis. The x value is?
-6.
Is it included?
No.
No. So I'm
So
going
why
to
is
go
it
parentheses
negative?
-6.
Because I thought if it was an open circle, it's continuing.
Open circle. It stops there, but it just never gets to it.
Okay.
It's kind of like going to the door and you're going halfway to the door, halfway to the door, halfway. You never get to the door.
Okay.
But it's a boundary for you. All right, so you start at -6 and you move along the graph. Now, you're always going to be moving in this direction, from left to right. So as you move along the graph, we have a graph. Then we get to this point.
-2.
Do we stop here?
No.
No.
Yes. Oh, no.
No, we jump up here. And then we move along this second piece and come all the way down to this point. Do we stop here?
No, you go to that.
Jump.
Ah, that's the problem. There's a jump here. Are there any x values between 1, -1 and 3, 2?
No.
No. At -2, 1, there was an x value. This is -2, 5, by the way. Not 2, 5. It's -2, 5.
I put it up there.
It jumps up to here. So as you're traveling along here, you can jump up here and you still have an x value. -2, -1, 0, all the way up to 1. But in between this 1, -1 and 3, 2, there's absolutely no graph. There's nothing here. It's a void. So when I say, when does my domain stop, you say
-6 to 1.
1.
1. Because we're moving left and right, the only coordinate you're concerned about is x coordinates. So it stops at 1 bracket.
So why is it that it's okay to have 2 -2s?
Where? Oh, here? Because this one is included and this one is not. It's just that the point is here, and if you want to think of it, you're going to put this inside of there for the domain purposes. We're not worried about range. Range is what's separating them. If the ranges were the same, they'd be right inside of one another.
So we said the brackets mean that, what does the brackets mean?
Included.
Included.
Included. So as we move from the left to right, we have a graph, 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 and then at 1, it stops. When does it pick up again?
3.
At
Back
3. Do I include it?
Union. I mean,
No.
union.
No.
Intersection.
Parentheses.
I'm sorry.
I don't know what you're talking about, Willie.
Okay.
So, starts at 3, where does it go?
Infinity.
Positive or negative?
Or
Positive.
Positive, because when we look at this arrow, we're only concerned about it's going to the
Left.
right.
Right.
Again, Willie, we're not worried about what you're saying right
Okay,
now, because
okay.
you must be drunk or something.
Yeah.
And in between them goes a union, to
Uh,
piece the pieces together,
Because of the void.
because of the void.
How is this positive? Oh, I don't
How's what positive? The infinity?
yeah.
Because when you look at this arrow, you're only concerned about left-right motion. This arrow is pointing to the
Right, and
right.
right is positive.
Yeah, don't be worried it's going down, that's range.
Gotcha.
That's range. Now, well, while we're talking about it, range, what's the range of this function? How far down does it go?
It goes to
-7.
-6.
Positive 7?
-7.
Oh, infinity.
Negative infinity. Why? You're all looking over here at this
That's
branch.
the
Come way over here. There's this arrow. This arrow is pointing down. That means it is going down to negative infinity. Now, when you come up, range is harder than domain only because there could be more than one y value. See, with x's, as you move across, you're only going to have 1 point on the graph, and it's real easy. With range, you have to be very careful that it could be more than 1. So as I go across here, how many times am I hitting the graph way down here?
Just one.
Once. It's from the arrow. It's hitting the graph once. As I move up here, how many times am I hitting the graph?
Twice.
Twice. So all the way up through here, I still have a domain. So negative infinity, and I'm coming up and I'm coming up. How many times do I hit the graph here?
3 times.
3 times. So that still must be in the domain because there's at least one y. How far do I get this graph going until I can't get it anymore? To 5. So the range on this thing is negative infinity, and you bring this horizontal line up, and as long as you hit the graph once, it's part of your range. So it goes from negative infinity all the way up to 5. Is 5 included?
Right here.
Open circle.
Oh.
Open circle. So the range on this thing is negative infinity all the way up to 5. There's no voids in my y values. There's no voids in my y values. All the way up to 5. It's like pulling teeth.
That one is blue too,
Is there a
because
union
I thought
in
it
this
was.
one?
No, this one, there's something. As long as there's 1, you're fine. X values, you should only have 1. And as long as there's 1, it's part of the domain. Y values, at least 1. At least 1. All right, I'm not going to do the f of and the to evaluate points. That's the easy part. I want to get to the last picture.
I want to go back to that problem.
Why?
Because I'm looking at these closed circles, and I was thinking if it was a range, it would go from negative infinity to the closed circle, be one part.
Okay. Negative infinity to the first closed circle.
Mm-hmm.
But if you draw the horizontal line, how many times does it hit the graph?
Okay.
3. So if you go above that, does it still hit the graph someplace?
3 times again.
Yeah. And it keeps hitting it until you get up to.
Five.
There's nothing missing. I could draw a quick picture of something missing. Quick picture. Actually, it's going to be similar to the last one. But a quick picture, let's just use that line right there. If I have something that looks like this,
There's a big gap.
and I'm talking about what's the range of this. If we move, well, let's talk about domain first. If we move along the x-axis, is there a gap in the x-axis, x values?
Yes.
Yeah, there's a gap from here to here, so that's a void.
That's an X.
So you'd have, something all the way up to here, and then something all the way to positive
Right.
That's
infinity.
when you union.
Now, if you're talking about the range, is there a range as we're moving up the y-axis? Well, yeah, negative infinity until we get where?
The first point.
To here.
Oh.
You remember, it has to hit the graph at least once, and after this, does it hit anything?
No.
No, until you get to here. So this is a void for the y values. So you got to be really careful. Are you looking horizontally or are you looking vertically? All right, let's go to that last picture. Which looks like this. Something coming up and coming down, and something coming down. And that's an arrow, and there are no others. Again, when you get those solid points, you need to get them labeled. What's the coordinate of this point here?
Negative 2.
-2, -2? Oh, I hate that. I should have made it different. I like different numbers so we can talk about them.
Mm-hmm.
The one way up high here? 2, 7. The one way down low here?
6,
6, -1?
Yeah.
6, -1. All right, real quick. What's the domain?
negative infinity.
Negative infinity, because it's going off to the far left
Negative 2.
to -2. Which -2?
Included.
Which -2? The
X.
first one or the second one?
The first.
It's the first one, because domain is talking about
The X value.
x values. So that's one reason I don't like them being the same, but that's all right. But then we have a void Remember, there's this void here.
Yeah.
There's nothing between x equals -2 and x equals
2.
+2. So we're going to have a union to put pieces together. When does the void stop?
2.
At 2. And then we have a domain all the way up to
7. Wait.
2,
6.
6.
6.
Okay.
That's why I have those
I was
points.
on the Y.
And they're both included. Yeah, that's the danger. You got to be knowing where you're looking.
X in here.
Yeah. So the domain is from -∞ to -2. We have a void, and then it starts up again at 2 and goes until 6. Now, when you're moving your finger along the curve, you're actually moving it up and down, but your thoughts should be, how is it moving
Side
left
to
to
side.
right, side to side. All right, range. Now we want to be looking up and down. How far down does it go?
Negative infinity.
-∞, because of this arrow over here is pointing down.
Up to 2.
Up until
2. 2?
2.
Or is it negative? Okay, negative.
Oh wait, we're looking at the
Y-axis, up and down. So you come from the -∞. Is there a graph? Is there a graph? Is there a graph? Is there a graph? When does it stop?
oh, into the little
the
curve
7?
thing.
All the way up to
Oh, the
7.
See on that one right there,
And it's a
That's what's
bracket.
confusing me.
that one right there you went up to the curve. That's why I'm confused. And that one
Over
right there you
here?
went up to 7. Yeah.
You come up to the highest point on the y-axis. So as I move it and I say, is there a graph? Is there a graph? I'm answering yes. And then when I get here, the answer is
No.
no. So as I move up from -∞ and I say, is there a graph? When do you say no?
When they hit that 7.
When you hit that 7. Anything after the 7 doesn't exist. Below the 7, there's something there. Left or right.
So it's something there because it hits a point.
It hits a point on the graph as you're moving from the bottom to the top. It only has to hit one point. It doesn't have to hit lots and lots of them.
See, I would think that would be infinity because it's an arrow that goes up on this one over here.
There's a, oh,